All right, we're going to start out by looking at 3 1. As I said, we'll split it up into 2 days. We'll do part today, part tomorrow, and then same with 4 1. We'll do part of it tomorrow and part of it on Wednesday. So on the calculator, I think some people have kind of noticed it, or maybe they mentioned it. They've seen these buttons, these sine, cosine, and tangent, and they have a -1. Right? And I said, we'll talk about those at some point. Well, now is some point. We're going to look at what those are. So the idea of inverse trig is it's used to undo regular trig. It's the opposite. So for example, if I took a number and I add 7, the opposite would be
-7.
subtract 7. That's like the inverse of adding, subtracting. If I took a number and I multiplied it by 5, to undo that I would divide by 5. Yeah, inverse. If I took a number and I squared it, the inverse of squaring is square rooting. Okay, so same thing here. If I took an angle, and let's say I took the sine of 15, okay, and I get that number. If I take the inverse sine of that number, 0.25881, what do you think I'll get back when I hit enter?
Negative. Cosine. 0.25.
So inverse sine
that number.
does the opposite of
So
what
it's
regular sine does.
Negative divide by.
So I took, if I plug in sine of 15, I get that. Now if I do the inverse sine of that,
It would just be the negative.
what number do you think I'm going to get
15.
back? Yeah, I get 15 back.
Oh.
Right? So when you do sine and then inverse sine, it undoes what you just did. Right? They cancel each other out. Right? So that's inverse trig. It's used to undo what you do with a regular trig function. Okay, so first thing is, how do we write inverse sine? Well, in inverse cosine and inverse tangent. There's 2 ways. Okay? One way you can write it is the way the calculator does. Okay? It writes a trig function and it puts a -1 up a little bit higher. Okay? What's confusing about putting a -1 up higher is usually when you put a number up higher, it's an exponent. When you put a -1 up higher, it's just a special symbol that means inverse. That -1 has nothing to do with raising something to the -1 power. Nothing. It's just like a special symbol. Okay. So the other way you can write it, if you do not want to write the way I have on the left, you can do it the way on the right. You can write arc sine. It's exactly the same thing. Arc sine, inverse sine, they're just different ways of writing the same thing. Now there's 3 other inverse trig functions that we don't have up there. There's no inverse secant, inverse cosecant, and inverse cotangent. We can do them. We generally don't focus on those because we don't have buttons for them on the calculator. And anything you can do with the 3 that are not on the board, you can do with the 3 that are. So that's why we use those. Okay, so any question first on the abbreviations? Okay, from now on, I'm not going to write out the word, INVERSE. I'm not going to write it all out. Okay, I use this abbreviation, the -1. That's how I do it. All right, I think I'm going to come back to that in a second. So next, I want to just compare how this is compared to what we did last week. Okay. When we did unit circle, this is the kind of problem you would have seen on the test. Okay. I gave you a trig function, I gave you an angle, and then I would ask you to tell me what the question mark is. It's like the sine of 30 or cosine of 45. Okay. We always did multiples of 30 and 45. So any question on what it looked like last week? So I gave you this, and you gave me what that number would be. This week, it's reversed. Instead of me giving you this angle, I'm going to give you this number on the other side. Okay? So with inverse trig, I give you the number on the other side, and you have to tell me what the angle is. So that's the difference. Last week I gave you the angle. This week you give me the angle. So that's kind of important to understand. Okay? When you use inverse trig, that is what you are always doing. Inverse trig is always used when you want to find an angle. So where are we eventually going to use that? Well, on Wednesday, I'm going to give you a triangle, and I'll label some sides in it, and I'm going to ask you to find the angle. Right? And the way that you're going to have to figure out an angle in a triangle is with inverse trig. So that's what inverse trig is. It calculates an angle, kind of like Pythagorean theorem calculates a side. Right? Pythagorean theorem has nothing to do with angles. Pythagorean theorem is all about sides. And this is all about angles. So any question on the difference between last week and what it looks like this week? So let's look at this. What I have is a table, and I've got some different angles in the left column, and I want to take the sine of each one of them and get the answer in the right column. That's all. And I want to show you what's going to happen. Okay, because the problem is when we do inverse trig, there potentially could be more than one answer to the question. Well, we don't want that. Okay, we want to make it so that there is only one answer. So technically, if there's more than one answer, how are we only going to do one answer? Well, we're just all going to agree on what answer we're going to give. Okay, we're all going to say, okay, we'll give the answer between this number and this number. That's the one we're going to use. Okay. So this table is going to kind of show you what happens. Okay, let's plug in these angles. Okay, if you look at the left-hand side, all of these angles are in what unit?
Degrees.
They're all in degrees. Okay, so just make sure when I do this, my calculator's in degrees. Okay, so the sine of 30 comes out to 0.5. So now, if I do inverse sine of 0.5, what number is the calculator going to give me back? 30. Yeah, so it undoes it, gives me back what I started with. If I do sine of 65, I get about 0.906. Now, what would happen if I do inverse sine of 0.906? I'll get back 65 or about 64.9 because I rounded it. Okay. It's a little bit off. Let's do the sine of 90. Okay, we get 1. And what if I do the inverse sine of 1?
90.
I will get exactly 90 because that's not rounded. Okay, and now let's do 150. Sine of 150. 0.5. So if I do the inverse sine of 0.5, what am I going to get back?
Hopefully 150. Wait, but 30 is also the same.
We already did this. We already did the inverse sine of 0.5. What did it give us back?
30.
It gave us back 30. So there's a problem where when you do inverse trig, you could get two different answers. The sine of 30 is 0.5. The sine of 150 is 0.5. So when you do inverse sine of 0.5, which one is it going to give you back? They're both correct, but we only want to get one answer, and we have to agree on what one answer it's going to be.
30.
So it is going to give you back the 30. It will not give you back the 150. Right? And there's a reason why. So we'll talk about what that reason is. All right. And there's other numbers that have a sine of 0.5. I could do the sine of 390. That's also 0.5. There's an infinite amount of numbers I could put here and get 0.5 as the answer. But if I do inverse sine of 0.5, it will always give me the 30. Okay? It's like the first one. So how are we going to know which ones we use? So when we're dealing with inverse trig, when it's inverse sine, we're always going to give an answer between negative 90 and positive 90. Okay? That's why when I did inverse sine, it didn't give me 390. It didn't give me the 150. It's always going to give you an answer between negative 90 and 90. If you're dealing with radians, it's going to be negative pi over 2 to pi over 2. Okay, and if you're thinking, well, what's the big deal? Why do we have to make sure we give the right one back? Because I'm going to ask you for one answer. Right? And the one answer that we give, it has to be in these two numbers, because that's also the way the calculator does it. Okay? Otherwise, if we don't agree on the answer we're going to give back, then there's infinitely many different answers. That's going to get confusing. So for inverse sine, we're all going to agree it's between negative 90 and 90. When we deal with inverse cosine, the answer that we're always going to return is between 0 and 180. So if you have a choice of more than one answer, and you're dealing with inverse cosine, pick the one between 0 and 180. There will never be more than one answer between 0 and 180. Never happen. All right, so let's say I did the cosine of 40, and then I did the cosine of 400. They come out exactly the same. When I do inverse cosine of 0.7660, good enough, what number is it going to give me back? It's going to give me, yeah, probably 39.9 or 40.000, because I rounded it. But it's going to give me back the one between 0 and 180. 400 is not between that. Okay.
So it'll most likely it would just be the smaller one?
Yeah, well, whatever the one is between 0 and 180. And let's look at this one, inverse tangent. When we do inverse tangent, if we have a choice of more than one answer, we're always going to pick the one between negative 90 and 90. But how is that negative 90 to 90 different from that negative 90 to 90?
Good.
It's just less than and greater than, not less than and equal to.
Right, it doesn't have the equal to. That's because if you actually try to do tangent and you use the number 90 itself, you get an error. You
Why?
can't use the number 90. Why?
Yeah.
Because there's a vertical asymptote in the graph. I can just graph it and show you real quick. Type it in. Tangent. $90 is right there. And if you try to go to 90, it's a vertical asymptote. We haven't studied the graph of tangent. We actually don't even study that graph in this class. It does help this make more sense, but it's just something we don't study. And same with negative 90. Negative 90 is right there. Another vertical asymptote.
So does that mean like multiples wouldn't be a thing either? Like would also be an error? Like,
Yep, we're not going to look at multiples. We're going to always stick with the answer between negative 90 and 90.
Okay.
Yep. Good. So like if I did, let's look at this one. Let's do the tangent of, I'm just going to pick a number, tangent of 20. And then let's do the tangent of 200. Tangent of 200. I think those will come out the same. Yep, come out exactly the same. If I do inverse tangent and type in that answer, that's just a short way of typing it all in, which one is it going to give me back?
20.
Yeah, it's going to give me back the one between negative 90 and 90, which is 20. Yep. Okay, so even though inverse trig is undoing what we did, when you undo this, you do not get 200 back. You always get 20 for that particular number. Okay. All right. So let's look at this. So this is a chart that has all the different angles we did last week. All the multiples of 30 and 45. And then it has the sine, the cosine, it has all of them. Okay, so it's got every angle and then all the trig functions. We're going to use this to figure out the inverse sine of 1. Okay, we're going to look it up on the chart. So, what did I say when you use inverse trig? What are you trying to figure out?
Degrees.
Degrees or radians, which is an angle. You're trying to figure out an angle. So another way to think of this question is like this. The sine of what angle would come out to 1? That's what you have to figure out. The sine of what angle comes out to 1? So, to do that, look at your chart.
Should we just draw the test?
It's already, yeah, it'll be on the test. It'll be part of the question.
We couldn't have that.
So to figure out what angle you can take the sine of and get 1 as the answer, go to the sine column, keep going down the column till you find a 1, and then go over and read off the angle that's in that row.
So 90.
So yeah, if we go down, keep going down, there we go. So we have two choices, 90 and negative 270. The way I got the negative 270, I just subtracted 360 from it. Okay, so each angle on this chart has the positive and the negative, because it depends on which one you need. Depends on what you're doing. Okay, so you got both. When we're doing inverse sine, what did we say we have to be between? What two numbers?
Negative 90 and 90.
Negative 90 and 90. So out of the two numbers,
90.
we want to pick the 90. Yep, so that's the answer. So it's 90 degrees. Or, what if they wanted the answer in radians?
Pi.
Pi over 2.
Pi over 2. So it's just a matter of which one they want.
Now, if it doesn't specify, you have to give both.
No, you could just give one. The test will specify. Right. That's how you find the inverse sine of 1.
Where'd you get pi over 2?
Pi over 2.
Okay, in radians. I get it.
Yep. So you got each answer as a positive and a negative, and as a radian and as a degree. You got all the different combinations you would need. Okay. Any question on that one? Let's try another one. So the inverse sine of negative 1. Okay, so what does that mean you're really trying to figure out? The sine, yeah, of what angle would come out to negative 1? So you're going to go to negative 1 in the sine column and go down till you find the angle. Okay, so what angle is in the row for the negative 1 in the sine column?
270.
Okay, so we're right here. Right, we're looking at this row. Now we can either put 270 or negative 90. What's the one we need to put? Right, we've got to be between negative 90 and 90. So 270, even though it is another answer, it's not the one that we agreed we're going to use. Okay? Because we have to agree on the same one, but then when we start to do stuff later on, it's not going to work. So negative 90. Or if they wanted it in radians, that's the same as
Negative pi over 2.
negative pi over 2. Okay, again, we don't have to write both. It's just a matter you need to know how to find both depending on what unit they ask for. All right, let's try this one. Inverse sine of 1/2. So you're going to you go into the sine column, go down until you find a half, and then look at the angles.
30 degrees.
Let's see. So we got a half there. Yep, I see it there. And then somebody else, you saw it where else? It's not under 120, but it does come up under 150. So So this time the 1/2 comes up twice. It'll never come up more than twice. So you're not going to find 1/2 anywhere in this column. Maybe -1/2, but not 1/2. So now you got 4 choices: 30, -330, 150, or -210. What's the answer that we're going to use?
30.
30, yep, because that's between -90 and 90. Okay, let's try this one. Inverse sine of √2/2. Okay, √2/2.
45.
Okay, so you can go down to the sine column, go to 1/2. I'm sorry, go to √2/2. There you go. And it does come up somewhere else.
135.
It does come up.
We're going to use 45 because it's in between 90.
Right. So if you took the inverse sine of √2/2, the answer that we would get is the 45. Or, in radians, pi/4. Okay. And let's try this one. Inverse sine of -√3/2. Okay, so where's the first time that we see -√3/2
60.
in the sine column?
240.
240,
So yeah, let me erase this.
240,
Negative.
300.
So you said 240?
300.
Okay, which one of those answers is between -90 and 90?
Neither.
Neither, then that's, we gotta keep looking. It must come up somewhere else.
300.
Mhm.
-60.
Comes up right there. So now, which answer there is between -90 and 90?
-60.
-60. Question?
No, I'm
No.
just saying.
It's the same
Okay.
thing, well.
So, any questions why these are, it's not that they're wrong, like if you do that on your calculator, you put in the sine of 240, you will get that. But if you do the inverse sine, you won't get 240. You're going to get -60. Okay, because
So is
that's,
the answer 300 or -60?
well, what do we have to be between?
Oh, so it'd be -60.
Right, we have to be between -90 and 90. And if you're like, well, what if there's more than one between -90 and 90? No, there never will be. If there's more than one, then you picked the wrong row. Okay, there will only be one answer. So -60. Or if they wanted that in radians, what would that one be?
Pi over 2.
-pi/3.
-pi/3. Yep. So for homework, if you need that chart, it is it's online. I think it's in a folder called Handouts. It's right in where the homework is. All right. So now let's look at this one. Inverse cosine of 0. All right. So now we got to switch what we're thinking a little bit. We're not between -90 and 90.
We're 0 and 180.
Right. If you do -90 to 90 here, it's going to mess you up. Okay, we have to do 0 to 180. So, another way to think of that, the cosine of what angle, that's what I want to know, comes out to 0. This is the same question. The cosine of what angle comes out to 0.
90.
Okay, so let's go down cosine, 0. Couple answers there.
And then 270.
And it does come up again.
But we want to use 90 because it's
They're
in
both
between
90.
180.
Right. Because this one, if you say, well, I got to be between -90 and 90, that's wrong because there's 2 different answers to pick from. If you ever have a choice of 2, then something's wrong. Okay, 0 to 180. No, no, no. The only one that works is 90. So that's 90 degrees. Okay, any question on that one? All right. How about inverse cosine of -1/2? And if you forget the negative, yes, it will come out wrong. Okay, you got to use the negative.
120.
And you have to be in the right column. Make sure you're in the cosine column. There we go. And where else does it come out?
240.
Yeah, it comes up over here, but we know we're not using those answers.
It's 120.
We got to use the one between 0 and 180. Yep. Now, some we can check on the calculator, some not as easy. We could check that one. Inverse cosine of negative 0.5. Yeah, exactly what I told you. Okay, out of the 4 different answers we saw, it gave us back the 120. All right, any question on that one? All right, let's do one more with inverse cosine. So negative root 2 over 2. So on the
Negative.
Okay, let's go down. There we go.
225. So you use 135.
Yep, so that's, those answers aren't between 0 and 180. That answer's not. That answer is 135. Okay, and if they ask you for the in radians, it would be 3 pi over 4. Because the problem is if you try to do this in radians on the calculator, it's going to give you a decimal. It'll never give you this 3 pi over 4. Okay, but the chart will. Okay. All right, so that's 135. Any question on it? Okay, so we did inverse sine, we did inverse cosine. This chart also has things for inverse tangent. We're not using it. I mean, sorry, it has inverse cotangent, secant and inverse cosecant. We're not using those. Inverse tangent we are using. Okay, so inverse tangent of square root 3. Okay, so first thing, what are we supposed to be between?
Negative 90 and 90.
Okay, we're back to negative 90 to 90, but
We can't use those numbers.
we can't use those numbers. And if you look at the chart and you try to go to 90 on tangent,
They're undefined.
it tells you you can't use it. So you should know.
It's 60.
Okay, so we're looking for root 3. We got there, and it is going to come up somewhere else.
240.
It does come up at 240. Those are not between negative 90 and 90. Neither is that one. So the only one we have left is 60. Yep. Or if they wanted radians, we would use
Pi over 3.
pi over 3. Now, just to make sure we remember, because eventually we're going to do ones that are not on the chart, how would I change that to radians if I had to by hand?
Multiply 180 over pi.
Pi over 180.
Pi over 180. And how many, what number goes into both of those? 3 does? How about even bigger? 60. How many times does 60 go into 60?
3. What?
When 60 goes to 61 times 60 goes to 80.
Oh, yeah.
Pi over 3. There's your pi over 3. Okay. How about inverse tangent of negative root 3 over 3? So, negative root 3 over 3.
150
So,
and 330.
negative root 3 over 3. Not seeing anything there between negative 90 and 90. We need to keep looking.
330.
330.
And we use the negative 30 on the bottom.
Yep, we use the negative 30. That's the only one between negative 90 and 90. Okay, so negative 30, or in radians, that would be what?
Negative pi over 6.
Negative pi over 6. Okay, so any question on finding an inverse trig function using that chart? Now, is every single angle that we could ever work with on that chart?
No.
No.
No. Which ones are?
Ones that we will work with.
30, 60, 90, 45.
Right. What's the pattern for which ones we see?
Multiples.
Multiples of what?
30.
30.
Yeah, multiples of 30 or
45.
45. Or somebody else said multiples of 15. Some of the multiples of 15. 75 is not on here, and that's a multiple of 15. But yeah, multiples of 30 and 45. So if you're trying to do a problem and the answer does not come out to a multiple of 30 or 45, it's not going to be on this chart. How do you know if it's going to be a multiple of 30 or 45? You're going to see numbers like this right here. You'll see ones, negative ones, zeros, 1/2s. You'll see root 3 over 2s, root 2 over 2s, and then the negatives of everything I just said. Okay. So if you have a number like 0.76, 0.76 is not in this table. So you're not going to be able to go down the column and ever find a 0.76. We'd have to do that, not with this chart. It would be something else. Okay, so if the answer is not in the table, we're going to use a calculator. So inverse sine of 0.65. Look at our table. If you go down the sine column, do you ever see 0.65? No. 0.65, that doesn't come up anywhere in the sine column. So we're going to type it in. Okay. Anybody remember how I got those?
Did you do second?
You press second. Okay. That's how you figure. That's how you do inverse trig. Press second, and in this case, we want sine 0.65. Okay. When you do inverse trig, what are you solving for? You're solving for what?
Angle.
The angle. Okay? So what mode you have your calculator in, either mode could be correct. It depends on if the directions say degrees or radians. Okay, I'm in degrees. So in degrees, it's 40.54, roughly. Now, if I wanted the answer in radians, two options. Either convert that to radians, or change your mode to radians and just type it in again. How do we change that to radians? Like on the calculator. Can you go to mode? Yep.
And then you go down to radian.
And then go down to radians. Yep. And then we can type in the same thing again. And we get 0.708. So either answer is correct. So now, what if I type in the sine of 40.54? What should I get?
Somewhere close to 0.65.
Right, so what we're doing is we're trying to check our answer. We did inverse sine to get that. Now we're going to do regular sine and see if we get our answer back. Did I get 0.65?
No, so now I have to try the other one.
How come I didn't get 0.65 back?
You're in radian.
I'm mixing the modes, yeah. This answer was a degree answer. If you want to check a degree answer, you need to be in the degree mode. If you want to check the radian answer, then that's fine. We can check that one. 0.708, and I get back 0.65. 0.65. So that's right. We'll switch back to degrees, and we'll check that one. Okay, so take the sine of 40.54. Now I'm in the degree mode. That was the degree answer. Hit enter. There you go. 0.6499. It's basically 0.65. Why isn't it exactly?
Because you're rounded.
Because I rounded, yeah. 40.54 wasn't the exact answer. Okay, there were more decimals to it. Okay. Any question on that one? All right. Let's try inverse cosine of negative 0.24. Is this one we're going to use the chart or we're going to use the calculator?
Calculator.
Yeah, why not the chart?
Because it's not on the chart.
Yeah, negative 0.24, that is it's just not a number you're going to find on the chart. Okay, so how do I type that in if I want the answer in degrees?
So make sure it's in degrees.
Okay, already in degrees, so that's good.
Second cosine.
Second, cosine.
Negative 0.254.
Negative 0.24. Okay. So what would my, if I wanted to write it for 2 decimal places, what would my answer be?
103.89. Yeah, 189.
Okay, I need a little bit more.
You just said 2.
Well, I want 2 decimal places, but the answer has
Degrees.
something else, degrees. We got to put a degree symbol on it. Yeah. If I write that, what have I just written? That's 103.89 radians. Yes. Okay, so we want degrees. So just make sure when you're doing the test, if it's a multiple choice question, look at the multiple choice answers. If they have the circle on them, then you know it's degrees. If they don't, you know it's radians. Okay, how about inverse tangent of 34.3? Can you use the table or calculator?
We cannot.
Can't use the table. Right? You're not going to find that in the table. Okay, so let's do that one. Let's do it in degrees.
88.3. Second tangent.
Second tangent,
34.3.
34.3. Okay. And what would that be to 2 decimal places?
0.33.
88.33
Degrees.
degrees.
Can you scroll up a little bit?
Okay, so that's the inverse
Or
sine, inverse cosine, inverse tangent. Now, let's do one like this. I want to do an inverse secant. Let's just do, I don't know, 1.75. Okay, let's look at the calculator. Do we have a button that has secant to the -1?
no.
No. Okay, we don't have a button for that. So we got to think
Don't
about.
you divide it?
We're going to do something with division. Yep. Can somebody tell me what I've rewritten that a couple times, like when we were using the chart? What does this mean? Inverse secant of 1.75 means I'm looking for what? Like I want to rewrite this using regular trig instead of inverse trig. I want to think about it a little differently.
Oh, so you did opposite.
So it means the what of what is going to come out to what?
Inverse.
So think about when I did like that, right here. I told you those 2 questions mean exactly the same thing. This is inverse trig. This is how you can think of it in terms of regular trig.
You're trying to get to that.
Same thing. I think I did it. So yeah, right here. Inverse sine of 1 means the sine of what angle would equal 1. I want to do that with the problem we have right now. Because if we can't think of the problem we have now with regular trig, we're not going to be able to figure it out. So we gotta rewrite it first. So what does the inverse secant of 1.75 mean?
Secant.
The secant of,
We don't know.
we don't know, is going to come out to?
1.75.
Oh, I get it.
Yes.
I
Okay.
understand.
So it means the secant of something is going to be 1.75. Now, think back to what we did last week. Secant is connected with another trig function.
Cosecant.
It was in the same row. It was across from that. Cosecant was above it. But
Yeah.
anybody remember what was in the same row as secant? Secant was on the right. This one was on the
Cosine.
left. What was it?
Cosine.
Cosine, yes. So if you know that the secant is 1.75, you also know the cosine. What was the connection between secant and cosine? If you know the cosine, what do you do with it?
Flop. Flip.
You do what with it?
You flip it.
You flip it, yeah. So if the secant is 1.75, what's the cosecant? Or what's the cosine? So remember, what's the connection between cosine and secant? If you know one, what do you do with it to get the other?
Do the
Opposite, divided?
No, not the opposite would mean you make it a negative.
So
Okay.
1 over 1.75?
Right, you flip it. Okay, if you know one, then to get the other one, you flip it. Usually we knew the cosine, and you flipped it, and it gave you the secant. If we knew the sine, you could flip it to get the cosecant. And if you knew the tangent, you could flip it to get the
cotangent.
cotangent, yes. So what we've just done is we've turned this from a secant problem into a cosine problem. That's good. We have a button on the calculator for cosine. Now, the last step is to change this back to inverse trig. How would you change this back to inverse trig? It would be the inverse cosine of what?
1 over 1.75.
1 over 1.75 equals, we don't know. That's what we're trying to find. Okay. So if you have an inverse secant, cosecant, or cotangent, the pattern to figure it out is change this to the trig function it's connected to, and take this number and flip it. That's how you have to put it in on the calculator. Okay, so remember, inverse secant, actually I'll just put them right here. This changes to inverse cosine. Inverse cosecant is connected with which one?
Cosine. No, wait.
Think about last week. Think about which one it's across from.
Sine.
Which one?
Cosine?
No.
No, cosine and secant are across from each other.
Sine.
Sine.
And then tangent.
And tangent and cotangent. So if you have one of the trig functions underlined in blue, you need to change it to the trig function that it's pointing to above. Once you change it, you take this number and flip it. So you have to do two things. Change the function, flip the number. So let's type that in, see what we get. Inverse cosine of 1 divided by 1.75. I didn't close my parenthesis, is that okay?
No.
Yes.
Oh, wait. There's nothing.
Well, I don't have anything coming after it. So whether I close it or not, it doesn't really matter.
But if there was something after.
But if there was something after it, yeah, it would have mattered. So 55.15 degrees. Okay, let's try another one of those. Inverse secant of 1.45. So first question you ask yourself, do you have a button for inverse secant? Nope. Then what do we change it to?
Cosine. Inverse cosine.
Inverse cosine, yeah. So we're going to change it to inverse cosine. And now can we just use the same number?
Yeah. But with on the bottom.
Right, we got to flip the number. So flip it. Okay, so inverse cosine of 1 divided by 1.45. Can you turn that up? Thank you. So inverse cosine of 1 over 1.45. Now I just type in. Second, inverse cosine, 1 over 1.45. So 46 point, well, it would round up to 46.4. All right. Okay, let's try that one. What is this function?
Sin. It's gonna be.
Well, just how do you pronounce that?
Oh, cosecant. The inverse.
Inverse, yeah. Inverse cosecant. Do we have a button for that?
No, so you have to do the inverse of
So we have to change it to the inverse of sine.
Yes, sir.
And we can't use 2.6. What do we have to use?
1 over 2.
1 over 2.6. Yep. You only have to do that if you don't have a button for it. If you have a button, you just type it in. Okay. So inverse sine of 1 over 2.6. 22 point, let's just call it 2262. And if they want it in radians, I haven't been doing those, but you would just put the mode to radians, type in the same problem. Everybody know how to type in the last thing you did on the screen? If you want to redo it, you don't have to type it all over again. You can just put it in radians, and then press second, enter. And it'll type the last thing. And if you keep pressing it, it'll keep going back through other things. Maybe it goes back 20 or 30 things. Okay, and how about this one?
That's the inverse of cotangent.
That's inverse cotangent.
So
Do
you're
we have a
gonna-
button for it?
No, so you're
Nope.
going to the inverse of tangent.
So change it to the function that it's connected with. And what do we do with the 0.35?
1 over 0.25.
Right, you have to flip it. You only have to flip it if you change the trig function. If you don't change the trig function, don't flip it. Okay. All right, so inverse tangent of 1 divided by 0.35. Inverse tangent 1 divided by 0.35 gives us in radians 1.23. Or we want it in degrees. And how do I type it in again without retyping it?
Second enter.
Second, enter. 70.71. Okay. So now, if I took the tangent of 70.71, what should I get?
You should get 1 over 0.35.
Yeah, I should get whatever that is, 1 over 0.35. I don't know what that is. Let's check it. Yeah, pretty close. Okay. So I can check my answer. All right, so that's how you do inverse trig when you don't have the button on the calculator, when you do have the button on the calculator, and on the table. Okay. Any question on those three things? Okay. So that's the first part of 3.1. Okay, so that's the homework for tonight. If you don't have a calculator, I would recommend doing 22 to 33 now, because you need a calculator for all of this.
Sorry, yes, sir.
The 13 to 20, I think those are, I think most of those are using the table, which you can get at on Schoology. And it's going to be on the test for you as well. All right, so you got a good amount of time, so please use the time to try to get a little bit of that done. If you finish it and want to show me, then you will not have any homework tonight. Whatever you don't finish, that's all.